Welcome to Chemistry Educational Academy. So what is Dalton's atomic theory? Before starting this video, please like, share and subscribe my channel and hit the bell icon. Then you will get the regular updates of my channel. Atomic theory was proposed by John Dalton. So he was an English chemist, physicist and materialist. So let's learn more about this scientist. He was born in a poor weaver's family in 1766 in England. He began his teaching career as a teacher at the age of 12. 7 years later, he became a school principal. He left Manchester to teach mathematics, physics and chemistry in a college. Most of his time he spent for researching and teaching. In 1808, he presented his atomic theory, which was a turning point in the study of matter. He is known for his atomic theory, Dalton's law, law of multiple proportions, as well as research of color blindness. He is also the first person who suggests symbols for elements. So below are the some of Dalton's symbols which he used for various elements like hydrogen, oxygen, nitrogen, phosphorus, carbon and sulfur. And also he showed how atoms combine to form compound. These are some compounds which he suggested. Atomic theory was proposed in the early 19th century, laid the foundation for modern chemistry. So these are the main postulates of Dalton's atomic theory. First one is elements consist of atoms. So all matter is made of very tiny particles called atoms. So these atoms participate in chemical reactions. For example, oxygen atoms in oxygen element, hydrogen atoms in hydrogen element. And second one is identical atoms in an element. If you take any element, all atoms of a given elements are identical in properties. Properties means physical and chemical properties, but they differ from those of other elements. See, oxygen element and hydrogen element, these two elements shows different mass and properties. So this is the second point. And the third point is atoms cannot be created or destroyed. According to Dalton's atomic theory, atoms are indivisible particles, means we cannot be divided into small particles. But when they participate in a chemical reaction, these atoms cannot be created or destroyed to form new products. So this is called law of conservation of mass. So we can understand by using this example. Here 16 mass units of one oxygen atom, when it is combined to 2 mass units of 2 hydrogen atom, gives 18 mass units of one water molecule. Here the number of how many number of mass units present in the reactant, you will get the same number in the product also. Here atoms cannot be created or destroyed, but it rearranged, combined or separated in chemical reaction to form new product. Fourth one is compounds formed by combining atoms. According to Dalton's atomic theory, atoms of different elements combine to simple whole number ratio to form compounds. So this is called law of multiple proportions. So the relative number and kinds of atoms are constant in a given compound. If you take any reaction, the elements which are participate in the reaction, the elements are fixed in the form of compounds. Example, water always consists of hydrogen and oxygen in a mass ratio of approximately 1:8 proportion. So this is the limitations of Dalton's atomic theory. So it does not account for subatomic particles. Dalton said that atoms are indivisible particles, so we cannot divide it into small particles. But we know that atoms can be further divided into smaller particles called electron, proton and neutron. And the second one is it does not account for isotopes. Isotopes means the atoms of the same element having the same atomic number but different mass number is called isotopes. Here hydrogen shows 3 isotopes. Hydrogen having 3 isotopes. First one is helium, deuterium and tritium. These 3 isotopes shows different mass number and same atomic number. So this theory does not account for isotopes. And the third one is it does not account for isobars. Isobars means atoms having the different atomic number but show same mass number. Here the example of argon having 18 atomic number, calcium 20 atomic number, but they both having the same mass number, that is 40. So this theory does not prove the isobars. Third one is elements need not combine in simple whole number ratios to form compound. So this is not observed in complex organic compounds like sugar. Last one is this theory does not account for allotropes. For example, carbon has 4 allotropes: graphite, diamond, fullerene and graphene. This theory did not explain the differences in the properties of diamond and graphite. So this is the main limitations of Dalton's atomic